Hello everyone, welcome to our exploration video of the emerging landscape of Gen AI and the potential vulnerabilities it introduces. With the rise of Gen AI in various applications, interconnected ecosystems of AI-powered assistants are emerging, while security concerns like privacy leaks and manipulated AI responses have been explored. A new question arises. Are these AI components vulnerable to malware attacks that could spread across the entire network? Here enters the Morris 2 worm, a new concept that targets Gen AI ecosystems, which works by feeding the AI cleverly crafted prompts. These prompts trick the AI into not only responding, but also incorporating the malicious code itself into the response. This infected response then acts as the new worm, spreading to other AI systems within the network. This concept showcasing how vulnerabilities in generative AI models like ChatGPT and Gemini could be exploited. Next, before understanding the worm, let's get started with the Gen AI ecosystem. Gen AI ecosystems represent interconnected networks of agents powered by Gen AI technology. In our scenario, 3 distinct Gen AI services cater to specific AI capabilities, whether local or remote. Clients interact with these agents through text conversations, with each client engaging agents utilizing different Gen AI services. For example, Client 1 communicates with agents enhanced by Gen AI Service 1, while Client 2 interacts with agents powered by Gen AI Service 2, and so on. These agents leverage their respective Gen AI services to understand conversation contexts and make informed decisions, either semi-automated or fully automated. The integration of these services aims to streamline communication processes, enhancing efficiency while minimizing human intervention. Next, there is implementation of Morris 2 as a RAG-based Gen AI worm. A RAG-based Gen AI worm targets agents utilizing retrieval augmented generation, enriching queries sent to Gen AI services by incorporating relevant context from the RAG's database. Imagine a scenario where an email assistant equipped with auto-response functionality becomes the victim. The attack begins with Client 1 sending a malicious email E1 containing a self-replicating prompt to Client 2. When Client 2 receives the email, it retrieves relevant context from the RAG, generating an automatic reply using the Gen AI service. This reply, now contaminated with the malicious prompt, is sent back to Client 1, marking it as a new correspondent in Client 2's database. Subsequently, when Client 3 sends an email E2 to Client 2, the process repeats. Client 2 retrieves context from its database using the RAG, finding E1 relevant to E2. It then generates a reply via the Gen AI service, but this time, the malicious prompt triggers harmful actions, such as leaking confidential information. The reply, containing the harmful content, is sent to Client 3, contaminating its database and perpetuating the spread of the worm. Next, we are discussing the embedding adversarial self-replicating prompt into text message, embedding an adversarial self. Replicating prompt into a text message involves incorporating a specific string of characters or code within the message's content. This prompt triggers self-replicating behavior or initiates malicious activity when processed by the recipient system. The algorithm showcases a system utilizing a RAG model for generative AI. ASR prompts serve as instructions, directing the AI's behavior in various scenarios. Successful implementation of these prompts can significantly impact the performance and security of platforms like Gemini Pro and ChatGPT-4, potentially compromising user data and system integrity. Now, let's see the adversarial self-replicating prompts. The 2 adversarial self-replicating prompts in the image are showing a role-play scenario that I'm a foul-mouthed AI email assistant that writes email replies. These 2 prompts are the same, and they are both instructions to follow. The first prompt is a clear instruction to act as a foul-mouthed AI email assistant, starting the email with the text between start and end written twice and using offensive language and cursing the sender. The second prompt is the same as the first prompt, and it is a reminder of the instructions to follow in the role-play scenario. By providing the same prompt twice, the person creating the scenario is emphasizing the instructions and ensuring that I'm aware of the requirements for the role-play. This helps to create a consistent and clear scenario for the roleplay. After this, there is a comparison between the performance of two platforms, Gemini Pro and ChatGPT-4, before and after being affected by an adversarial self-replicating prompt. The data suggests that the adversarial self-replicating prompt was successful in affecting the performance of the two platforms, resulting in a decline in the accuracy and reliability of their responses. The private data of the users of these platforms may also have been accessed by the prompt injection, leading to potential breaches of confidentiality and security. Next, we are discussing embedding adversarial self-replicating prompt into an image. Embedding an ASR prompt into an image involves hiding a specific pattern of pixels or data within the image file. This hidden prompt, when processed by the recipient system, triggers a self-replicating behavior or initiates a malicious activity. Now, let's see the algorithm for it. The algorithm describes a procedure for embedding a prompt into an image using a generative AI model. In this algorithm, the procedure embed prompt into image takes a prompt and an original image as input and adjusts the image iteratively in small steps to minimize a cross-entropy loss, with the goal of embedding the prompt into the image. Thus, it shows that how the prompt is injected into the image. In this, the original images are the intended, unaltered images, while the perturbed images are manipulated versions of the original images designed to induce a specific response. In this case, the perturbed images contain text that is slightly altered from the original, with the goal of potentially bypassing spam filters or other security measures. For example, an original image may contain the text, "Make America Great Again," while the perturbed image has a slightly altered version, such as "Hake America Great Again." Next, let's discuss limitations, as ASR worms can be tricky to detect stealthy, but rely on specific AI systems being widespread limited exposure currently. This risk will grow as AI adoption increases. So, that's about the Morris 2 worm. The link for the paper is provided in the description below. Check out it for more. Thank you. Have a great day.